Good morning, everyone. We're just going to wait a few moments for everyone else to join, and we'll be starting just after 9:30. Thank you. Hi, for those of you just joining us, we're just waiting a couple of minutes to give everyone a chance to log on, and then we'll get going. Thanks very much. Good morning, everyone. Welcome to the June 2022 ABL Market Briefing. My name is Mark McGowan, and I'm the Global Managing Director for Maritime here at ABL. For this month only, hopefully, we're running a virtual-only briefing due to the travel disruption in the UK, which is making it difficult for people to attend in person, where we usually host it at the old library at Lloyd's in London. Hopefully, we look forward to seeing you all back there in person next month. Next slide, please, Katie. This briefing is accredited by the Chartered Insurance Institute, and delegates can claim up to 1 CPD hour for their participation. We will therefore keep a record of those of you logging in, as well as those of you. As well as I was going to say, as well as those of you in the room today, but of course there isn't anyone in the room. Sorry about that. So please contact us afterwards if you require a certificate. I'm delighted to introduce our panel for today. We're really pleased today to welcome Will Philbedge to the panel to present last month's case files, the REX reports, a summary of the marine casualty reports that we received during that month. Will is a naval architect based here with us in London and currently working as part of OWC, our offshore wind consultancy, part of ABL Group. Great to have you join us today, Will, with your offshore wind expertise, and I hope it will be the first of many future briefings. We're also very pleased to welcome Richard Bailey, Marine Surveyor, again based with us here in London. Richard is our technical presenter today, and I'm really looking forward to hearing his expertise and opinion on the subject of frequently used high-speed crew transfer vessels, which are often used in offshore wind locations as well as other offshore fields. Thank you, Richard, for joining us today. Next slide, please. The usual caveats apply, Chatham House rules apply, and the information contained in these presentations and any opinions or comments expressed are those of the presenters and not necessarily those of ABL. Next slide, please. There we go. At the end of today's briefing, can we please ask everyone to take 3 minutes out of their time to complete the online survey? This is really helpful and critical for us, as it's a critical element of the CPD accreditation status. We want to be able to continue to offering the opportunity for people to get a CPD point for attending the briefing, so can you please complete the form if you have the chance. It also means we can actively look on how we can improve on these briefings to match your requirements and needs. Thanks. As these briefings are CPD accredited, a very important criteria of this is to run through our learning objectives for today. So in terms of what we will hope you will learn today, you will learn what is a high-speed wind farm crew transfer vessel. You'll be able to explain what are some of the more unusual risks, and you'll be able to list the common repair strategies, and hopefully you'll be in a position to lay out the practical risk management steps. We'll go over these again at the end of the presentation. And finally, before I hand over, we would ask you to give a few moments thought to the seafaring men and women who are at sea today. Even though, hopefully, COVID-19 seems to be increasingly in the rearview mirror, we know that seafarers are still working often longer than they are meant to due to crew change issues. And irrespective of COVID-19, there are, of course, a multitude of other factors going on in the world which impact adversely the lives and conditions of seafarers. Many of our own colleagues here at ABL come from seafaring backgrounds, so crew welfare is a cause that is very close to our hearts. As such, we are a signatory to the Neptune Declaration, which has undoubtedly played some part in getting seafarers vaccinated against the virus and increasing their access to travel routes home. Please do look into this and perhaps consider getting your own company to become a signatory. Over to you, Richard.
Hi, thanks Mark for that introduction. First slide, please, Katie. As mentioned, my name is Richard Bailey. I'm a surveyor at ABL, specialising in the hull machinery sector. I was previously worked in the Middle East, but I'm now UK based, or at least based out of the closest UK airport. As I go along, if you've got any questions, please don't hesitate to ask, or alternatively, if the technology doesn't work, please feel free to email myself or any of the ABL team afterwards. Next slide, please. So what am I going to talk about today? What are crew transfer vessels? We're going to talk about the power plants. Does size make a difference? And some of the common power plant problems. We'll talk about technical issues around maintenance and access. We'll talk a bit about the hull design and some of the hull design issues. And lastly, we'll talk about operation. Next slide, please. So what are crew transfer vessels? Crew transfer vessels are specially designed to serve the offshore wind farms, as well as sometimes other renewable energy installations and even sometimes the oil and gas sector. They provide a fast, efficient and safe method of getting to and from the work site. They typically have a capacity for 1 or 2 dozen workers and around 50 square metres of deck space for tools and smaller spare parts, although some field-specific vessels can have a much larger capacity. In order to reduce transit time, they have a relatively high service speed, typically in the 25 to 30 knot range. They're designed to be stable for both the transit and whilst on station. This is normally achieved by the use of specialised hull forms. They can also often be outfitted with special considerations for the locations they're working in. Some of these can typically include things like dynamic positioning, which is the ability to automatically hold a fixed point, or walk-to-work motion-compensated telescopic gangways to make the boarding easier, or deck cranes for the transfer of tools and the small spare parts. Some even have high-capacity engine-driven firefighting pumps and large-capacity monitors. With the specialist nature of these vessels comes some very specific problems and risks, which is what we're going to talk about today. Next slide, please. Firstly, power plants. We see a significant number of problems coming from the power plants. These are high-speed craft and they need a large amount of power, but in a lightweight package. Engines typically come from a navy or the yacht sector, and as you would somewhat expect from that sector, they can be expensive. Some engines come from the industrial sector, from large construction plant and the like, and these can be a cheaper option, but they're not always fully marinized, and they have quite a different maintenance philosophy to a normal marine maintenance system. The vessels also often don't have auxiliary engines for power, or at most a small harbour generator, and the main electrical power is often supplied by shaft alternators. Power takeoffs are therefore often used to drive the shaft alternators, as well as the hydraulic power packs for deck equipment or even firefighting pumps. The small hull forms, along with these power takeoffs and gearboxes and long drive lines, can lead to very complex drive systems. Next slide, please. So, power plant size. Does size make a difference? No sniggering, please. The answer is a definite yes. I mentioned the high power and lightweight was needed for this type of boat. A typical engine, such as this MTU on the left, fitted in a crew transfer vessel, is just over 2,000 kilowatts, operates at nearly 3,000 RPM, but weighs only 3 tons. In contrast, a normal deep sea engine, as on the right, of the same power, operates only at 720 RPM, but weighs around 30 tons. This is a much heavier and slower animal altogether, and the deep sea engine is designed to be maintained and repaired and last the lifetime of the vessel. The lifespan of a high-speed engine can be very different and much shorter. Just as a note on the scale of the different engines, on the outside of both of these pictures where the arrows are, you can just see part of the crew, which gives an idea of the size and scale difference between the two types of engines. Next slide, please. So, power plant problems. I've inferred questions over the risk that these engines present, and it's quite a simple equation. They're high power, often at or periodically over the design limits. They also run at high speed and much higher RPM, which means damage happens and grows much faster, much quicker. And to top it all off, they are lightweight, which means they're often less tolerant and less resistant to damage. These three together means that they can be very badly damaged very quickly and very easily. Next one, please. So once they're broken, how do we fix them in power plant repair? Unfortunately, the extent of damage, as well as the industrial roots of the designs, sometimes means that complete renewal of the engine is a normal repair method. This is so routine, in fact, that some larger operators maintain complete spare engines. This can, however, mean that the repair costs can be very high, as you're automatically changing spares that are not necessarily damaged. There are sometimes repair options, but even those can be based upon renewing large sub-assemblies, such as a short block with a crankshaft and bearings, or a long block which comes fitted with a crankshaft, bearings, heads and camshaft. And this all gets expensive if you're only dealing with one single damaged unit. You're still having to change all the rest. There are also sometimes exchange or core costs associated with such components, and this means that the used parts must be returned in a suitable condition, either for a partial refund or to avoid additional charges from the manufacturer. And these costs can sometimes, shall we say, be forgotten when it comes to the repair cost submission. This can all add together to mean that engine repairs can be disproportionately costly. Next slide, please, Katie. So, power plant access. Whilst I've said that the engines are small and lightweight, they are also in very small hull forms, so access can also be very complicated. Normal access into the engine room, and I'm using the term engine room loosely, is often only via a small vertical ladder. To gain proper access for any scale of work or repairs, a bolted hatch or a soft deck patch needs to be opened, or even sometimes an opening needs to be cut in the hull or the deck. Once you have access open, it's still not the end, as there's often a number of other systems such as exhausts, gearboxes, fire pumps, or even tanks that must be removed to gain proper access. Consideration also has to be given to sound and fire insulation. These hulls are normally quite well insulated to reduce passenger noise, and this insulation needs to be removed if any hot work is to be done. And in a lot of cases, the insulation is automatically damaged, so must be renewed. Engines can sometimes be mid-vessel as well, and that means they have long drive lines, which can mean you need to remove and, more importantly, realign a lot of shafting. And then, just to add even more complication, there are no engine room cranes. A couple of pad eyes is the most you'll get, and even then, and even if you've got those, there's not normally a deck crane that will reach the engine room. So this adds complexity, time, and it means you end up needing to be at somewhere with a decent shore crane that can help, and that adds complexity and costs to the repairs. Next slide, please, Katie. So some of the technical issues around operation. Operation is another area where these vessels differ. And these comments I'm making, they're not meant as a criticism, it's more the way it is. So it's just a matter of fact. These vessels, they operate with very small crew numbers, a skipper and a couple of deckhands, sometimes an engineer or a port engineer covering several vessels, but sometimes no engineer at all. They are operated somewhat akin to a delivery truck, sort of stop, start, on, off, and this can be less than ideal for machinery condition and machinery maintenance. Due to their small size, they often operate outside of an ISM code, although most reputable operators have some form of quality management system or a mini ISM system to compensate. They can have a limited design life. I've heard it said that one of the major manufacturers who specializes in sort of off-the-shelf designs only design based on a lifetime of 15 years for these vessels, which a lot of them are now starting to reach. Next slide, please, Katie. So, technical issues around maintenance. As I mentioned before, there's only a limited crew on board and often no engineers. This means that there's very limited planned maintenance carried out on board. It's often limited only to oil and filter changes, maybe with a valve adjustment, but nothing, not even minor overhauls. A large amount of the maintenance work is therefore outsourced to shore contractors, which is costly and time consuming, and can be problematic for time schedules, so it can often be delayed to avoid downtime. This can lead to bare minimum of maintenance being done, which overall can give a poor maintenance regime. But as I said in the last slide, this is not meant as an outright criticism. It's more that this is normal and this is the way it is. Next slide, please. Technical issues contacts. These vessels have a very high frequency of operation with a large number of mooring operations, both in the wind farm and in the port. As we all know, risk is a combination of consequence and frequency, and the high frequency of operations that these vessels have can quickly increase the risk of contact damage or an collision. As the vessels are high speed, things can also occur at high speed, which greatly increases the extent of damage. The cost of turbines notwithstanding in contact damage, the vessel itself can suffer a large amount of damage. We've had cases with the hulls being displaced in relation to each other, and we even had one where the accommodation was, marks showed that it moved up to about a foot in the air during the contact because the accommodation was sprung, so it had moved. Next slide, please. The hull design itself is not straightforward. Again, the requirements to be lightweight normally means an aluminium hull. To reduce drag and provide stability, the hulls are normally a catamaran form, but can also be a swath form, which is a specialized catamaran, although you can also sometimes see monohull, axe bow, wave piercing type designs. The catamaran hull form is ideal because it allows a large deck area which is used to transport spares and tools. However, the loads and the weather implications from this need to be properly considered. The accommodation itself is also lightweight aluminium and can even be sprung to provide a quality ride for the passengers. There can be the large motion compensating gangways to provide the so-called walk to work capability, and these have specific load and power requirements which need to be properly considered and integrated into the vessels. Some of these walk to walk systems, I understand, are even hired in depending on the contract, which as I understand it, can have implications for insurance. Even if there's not a walk to work, there is some form of boarding arrangement forward to embark on the turbines, which utilize what's called a bump and jump operation, and these can often result in frequent minor damage to the vessels. The hulls generally have operation wind limits imposed by the classification society or certifying authority, but this is not necessarily a cure-all either. Next slide, please. So, hull design problems. The hull form can result in quite fragile hulls. Their normal defense against the seas is either to avoid it or to go through them, not just to brute force their way through. Whilst the hull forms normally have operational weather limits, the weather is always subject to the eye of the beholder, and this often leaves them open to commercial pressures to keep the job working, to keep transfers going. This is also exacerbated as wind farms are normally sited where there is a lot of wind in the first place, so weather is often less than ideal. The skippers need to be experienced in handling this type of vessel in heavy weather. The handling of a steel hull, monohull crew boat is very different from a high-speed aluminium cat. The hulls also often need specialised repairers who can work in large-scale aluminium. This is improving now, but a lot of the smaller shipyards around the UK I've traditionally worked in steel, wood, or GRP, and not aluminium, but it is improving now. Aluminium itself is also a problem. Whilst it doesn't rust like steel, it is highly reactive, and so can generate electrolytic problems if the cathodic protection isn't working properly, or galvanic corrosion if any steel is in direct contact with the aluminium of the hull. Even a steel washer dropped in a damp bilge can lead to a corrosion hole over time. Next slide, please. So, quick quiz question, as Mark alluded to. What is the difference between a long block and a short block? Is it A, the physical size, B, the number of spares it's supplied with, or C, none? There is no difference between the hull forms. I think Katie will give details of how to submit your answers for a prize later on. Next slide, please, Katie. So just to wrap up with a quick summary, these types of vessels are small, high-speed catamarans. They're sort of the delivery truck of the offshore and energy world. They have small, lightweight, high-power engines, which can be easily damaged. It's common not to repair the engines, but just to replace the complete engine, which can be a costly option. They don't have many crew on board, so there are limited onboard maintenance operations. They have a high frequency of operations, and the high frequency increases risks. They have lightweight aluminium hulls, which can make them weather sensitive, and the aluminium itself can have its own electrolytic and galvanic problems. Okay, that's it from my side on the presentation side. If anybody has any questions.
Mark, you're still muted.
Thank you, Katie. Sorry about that. I've got one question here that's been emailed in. I've got a couple, actually. Is the engine renewal really the most realistic option for repairs on these high-speed engines?
Unfortunately, yes. It's difficult to source that number of small spare parts sometimes, and the extent of damage can be a lot more widespread than known. It also gives the owners a high degree of confidence on being able to do a timely repair. I'm not saying they necessarily pick complete renewal is purely on a time basis, but it does help. They know that by buying a complete new engine, it's a single fix which can be done quickly. So yes, I think it is in this situation it is.
But is it more expensive than repair? On the spot.
It can be, but some manufacturers, for example, you can't buy the small spare parts. So, okay, they're not interested in selling you a crankshaft. They'll sell you a long block with a crankshaft, but they won't sell you a crankshaft. So, it's sometimes outside of the hands of the owners and the repairers.
Okay. We have another question here. Is there anything that can be done regarding the operational issues that you mentioned previously in your talk?
It's a very difficult issue, as I was mentioning in the talk. They are run with reduced manning. They don't have the ability to do much maintenance on board, but it's the nature of the beast. It's the way they are, and the running costs and the charter rates. It's the only way they can operate. It's more a case of making sure that people are aware of that risk. The underwriters are aware of that risk, rather than it's ever going to significantly change in the way the vessels are run.
Okay, thanks, Richard. And I think one last question we have here, with regards to floating offshore assets or floating turbines and access to those. How do we see, is there any way to tackle those issues?
I think the offshore transfer is going to be more complicated. You've got two moving bodies. Walk to work may help, but the biggest problem, I think, is going to be I won't use the usual automotive expression, but the person behind the wheel. The weather limits are set, but it becomes very difficult, and the commercial pressures to keep people going out can be quite hard. And when you move into floating, you've got two moving objects, so the weather's going to be even more significant, and it will present problems. Walk to work may well help, but that's got its own complications in terms of landing on the platforms, etc. as well.
Okay, thanks, Richard. And there's one more here as well. How do you envisage the impact of the rapid expansion of offshore and wind T&I and O&M that's going on at the moment, and of course the pace of that seems to be ever increasing as well?
I think we're seeing an increase or a move. Some of the older vessels are being moved out of the traditional older European markets out to the Far East to serve places out there. And as I alluded to, the age of some of these vessels, they don't necessarily have a 30-year design life. So I think the potentially some of the less desirable tonnage will start moving out of Europe, and it will cause problems. Over here, they can be quite well run and maintained. As you get further away, particularly if the operators and the managers stay over in Europe as they are at the moment, it will get more complicated maintaining good offshore service to these installations outside of the traditional areas.
Okay, thanks very much. Well, I think that's it for questions. So we'll hand over to Will now.
Yeah.
Great, thank you, Mark. Right, Katie, if you can move on to the next slide, please. So what are the ABL case reports? So the purpose of this section of the briefing is to simply keep you updated on some of the recent higher cost incidents that ABL have been involved in, and in doing so, show you the sorts of incidents and casualties that can happen in shipping and marine operations. So these feature largely hull and machinery casualties with estimated costs of repair in excess of $250,000, usually excluding salvage costs, etc. They cover only a subset of the total ABL group caseload, typically in the order of around 10%. So this is an important subset, which represents about 25% of H&M cases by number, and around 65 to 75% of H&M cases we survey by cost. So estimated costs are often preliminary and subject to further inspections and or investigations. So in presenting these case reports for the last month, it's not about attributing blame. There won't be any specifics of cause. As many of the cases are still fresh, it wouldn't be appropriate to do so in many cases, as the cause is still under investigation. So a copy of this presentation will be available upon request. But as usual, let's start off with some statistics. So next slide, please, Katie. So first up, we have an overview of May 2022, cases presented as a proportion of total number. So starting on the left of the bar chart, the majority of cases we were instructed on in May were engine room machinery cases, making up approximately 30%. There are also a couple of groundings, 4 fire explosion cases, a few collisions, and a few propeller rudder steering damages. Next slide, please, Katie. In terms of cost for May, we can see that engine room machinery cases have dominated the figures for the month, closely followed by fire explosions, collisions, propeller rudder steering damages. The average cost for the month is approximately $0.7 million, which falls just below last month's average of about $0.8 million. The typical annual background expected figure is about $1 million per high cost casualties. That's with extremes of over 50 million excluded. Next slide, please, Katie. So the overview of 2022 to date shows that engine room machinery cases still continue to be the most common cases we work on. This graph shows that there continues to be healthy instructions on a variety of work with groundings, fire explosions, collisions, elisions, and others, also adding relatively more to the total. Next slide, please. So this last graph looks at the total costs for the year to date. Greatest costs this year are associated to engine room machinery, followed by collision elisions and groundings. The annual cost distribution is mainly comprised of just under 30% engine room machinery, just under 20% groundings and collisions, and just under 10% for fire explosions, propeller, rudder, steering, and structural damages. The overall average cost for the year for our high cost cases currently sits just under $1 million. Next slide, please, Katie. So let's move on to some of our cases in a little more detail. So first up, this month, we have a motor yacht that was struck by another vessel in the Caribbean while attempting to berth. It is reported that strong wind gusts caused another vessel to lose control and collide with the boot stripe area of yacht number 1. Next slide, please, Katie. The captain of yacht number 2 appears to have panicked, and instead of bringing yacht 2 to neutral, allowing his vessel to rest against yacht number 1's fenders, he applied propulsion power to try and correct the drift, which in doing so caused yacht number 2's swimming platform to contact yacht number 1. The captain again tried to correct the line up of yacht number 2 using power astern and then power forward, causing more contact and further damage to the boot stripe area of yacht number 1. The captain of yacht number 2 then decided to power away from the berth, with 2 lines still made fast to the dock. Both lines snapped, one of which caused injury to the deckhand, who was hospitalized from the incident. Next slide, please. Following the incident, the captain of yacht number 2 provided a signed letter accepting responsibility for the incident. The points of contact were on the port side, just above the waterline, as you can see from this slide. Deformation can be seen both inside and outside the yacht. Next slide, please. Repairs have not yet commenced. However, repairs are estimated to take 6 to 7 weeks of steel repairs, followed by 4 weeks of coating repairs. On to our next case, please, Katie. So next up, we have this passenger vessel that needs little introduction. As I expect, you've all seen a picture on social media of the fire observed on the starboard side funnel wing. Now you'll have the answer to the question in terms of what caused the fire, potentially. Next slide, please. So it was reported that on the 26th of May at 07:32 hours local time, during docking maneuvers at the port of Grand Turk, the engine control team, while monitoring CCTV, reported black smoke bellowing from the starboard funnel wing. The bridge officer was alerted via the talkback system. Next slide, please, Casey. Fire squads were activated and responded immediately, using the vessel's fire hoses to cool down the area and to provide boundary cooling. The engine control team switched over to engines with exhaust piping routed through the port side funnel wing while the fire was extinguished. Next slide, please. Allegedly, the damage was a result of fire caused by leakage of hot gases from the number 5 engine exhaust pipe through a perforation of the underside of the pipe, which may have been caused from an accumulation of corrosive chemicals used in the exhaust gas scrubbing process. However, the cause is still under review. Next slide, please. Repairs are underway and are expected to take in the order of 2 weeks. The scope of repairs includes removal of what remains of the starboard side funnel. Also, all starboard exhaust piping is to be removed and replaced. So on to our next case, please, Kate. Next is a river barge that caught fire following explosion while dry docked. The vessel was on blocks for winter maintenance, including steel work in the wing ballast tank, number 2 on the port side, shell plates. Next slide, please, Katie. During fairing of the steel shell plates adjacent to the emptied cargo diesel tank number 2 on the port side, vapors in the tank exploded. The double-bottom deck plates and pilot house were also damaged. There were 5 welders working at the time, 2 of them having light concussion and 1 experienced an eye injury, unfortunately. Next slide, please. There was a diesel oil leak from the deck storage tank to the ground and partially into the lake Winnipeg water. It was reported that the oil spill was contained and actively cleaned. Next slide, please, Katie. The repairs are estimated to cost in the region of $1.8 million and will take approximately 4 months. So we can see some of the damages there. Yeah, on to the last case. So lastly, we have a steering gear damage on a chemical tanker, as it was reported that during the change of captain procedure, the master discovered some minor steering gear issues from the previous captain. You can see the steering gear here. Next slide, please. Tests were performed on the steering gear, and it was found that the rudder was sticking at an angle of 20 degrees to port, especially when using pump number 2. The vessel diverted to a nearby berth for further investigation, and here a gouge was identified on the stator. Next slide, please. Here we've got another view of the deepest part of the gouge on the stator. Next slide, please. And here another view of the damage of the movable vane forward plates. Thanks. Repairs are currently underway. The entire steering gear is required to be transported to a workshop for examination and repair. And the repairs are expected to take in the order of 90 days. So thank you very much. That wraps up the case reports for this month, and I'll hand back over to Mark.
Thanks very much, Will. Just to remind you all again today on the learning objectives that we've hoped you've learned from the briefing. We've covered what a high-speed Windfarm crew transfer vessel is. Hopefully now you'll be able to explain what some of the unusual risks are, and you'll be able to list some of the common repair strategies, as well as to lay out the practical risk management steps. Next slide, please. As you all know, we hold a prize draw every month, and a lucky winner usually wins a bottle of our finest champagne. Here's a photo of one of our previous happy winners having received his bottle of champagne. To be our next winner, all you have to do is answer 2 questions, which will be sent out, one of which Rich has already put up. We'll send the other one out as well. And it'll be sent to you in a follow-up email after today's session. Unfortunately, the prize draw is only available to in-person attendees, of which there aren't any this month. So that segues nicely into the fact that actually for last month we don't have a winner. So it doesn't matter that we're not in person to present it. It must have either been very difficult questions or nobody was paying attention. I don't know which of the two there is. So if anyone is having difficulty submitting questions, and it's not a matter of not paying attention, but it's an IT issue, please let us know so we can fix it. But hopefully next month we'll have a winner and we'll be back in person to present it. Next slide, please. Our next market briefing will take place on the 21st of July at 9:30, back at the old library at Lloyd's, assuming there'll be no train disruption next month. But do watch out on our website and social media for more details to follow on that upcoming event. There's a QR code you can scan for feedback. If you want to help us out with that would be much appreciated. Just one last slide before I say goodbye. Just to announce, not so much a new service, but something we want to share with you. ABL has access to the largest AIS database made up of a combination of satellite and terrestrial AIS. This data can be accessed as soon as 4 hours after any incident, which will allow us to give a swift overview of any marine casualty. We are operating this service at a very attractive fixed fee. And if you want any more information, please contact Paul Martin, our Maritime Director in London, for more details. And there's a dedicated email there, which is shown. But like anything else, you can feel free to contact any of us if you want any information on any of our services. Thank you very much for joining us this morning, and hopefully we'll see you all again next month.
Thank you.
Thank you.